All right, guys. So today we're going to solve an absolute value inequality graphically using a graphing calculator. Woo. So the problem is down here. 2 times the absolute value of x minus 5 minus 4 is greater than or equal to 2. So the first thing that we're going to do is graph the left side of the inequality. So that's from the 2 to this minus 4, and we're basically treating it as its own function. So basically rewriting it as f of x equals 2 times the absolute value of x minus 5 minus 4, and we're going to stop there. So what we're entering in on our calculator is exactly this. So let's go ahead and do that. So that is going to be 2 times the absolute value of x minus 5 and then minus 4. And that creates our absolute value. And then what we're going to do is we're going to graph the right side of the inequality as its own function. So that would be f of x equals. Now the right side is, all that's on there is 2, so equals 2. And that's all we're going to plug in our calculator. So press tab and 2 and enter, and that creates this horizontal line. So the next step that we're going to do to solve this absolute value inequality on our calculator is find the points of intersection. In order to do that, we go to Menu, Analyze Graph, Intersection, and you have to go to the left and right of each of our intersection points. So our first one is 2, 2, and then we do it again. So our second point of intersection is 8, 2. In order to be able to graph this too, I'm going to go ahead and find this vertex of our absolute value by pressing Menu, Analyze Graph, and that is a minimum point. So you have to click on the graph you want to find the minimum of and go to the left and right of it, and so there's my vertex. So what am I going to do now is I'm going to plot these points, these 3, on our paper so that we can work with it here. So the first point is, oh gosh, I've already forgotten, 2, 2. So here at 2, I'm at 2. And then the next point we had was 8, 2. So 2, 4, 6, 8. I'm up at 2. And then that vertex was at 5, 4, negative 4. So that's down here. So now I'm just going to connect these 3 points to make the absolute value and the horizontal line that goes through it. And right. Oop. Okay. Ooh, here we go. Okay, don't forget your little arrows to suggest that these go on forever. And I'm going to label these points. So this was at 8, 2. And this was at 2, 2 as our ordered pairs. So we found the intersection points, and I went ahead and graphed it here on paper. So my next step is to highlight the graph based on the inequality symbol. So the inequality symbol that I'm dealing with is this one, greater than or equal to. I still use what I learned in elementary school. Greater than is the one that doesn't look like an L. So this one doesn't look like an L, so it must be greater than. And it says greater than 2. This line is the line that represents 2, so where on my absolute value graph is greater than 2? Well, it's going to be above that line. So I have these 2 sections here above the line that I'm going to highlight to represent greater than 2. So here we go. So I highlighted 2 separate sections of my graph right there. 2 separate sections, which means that for my final step, I need to write 2 inequality statements to represent each of these sections. I'm only going to use my x values of 2 and 8. So that is going to be like this. So this is how I do it. I write, since I find it a little confusing to figure out what my inequalities are, I always write them first as x, and then I leave a blank to figure out later, and then 2. And then I write the second one, x, and I leave a little blank, and then 8. Okay, and then I go back and deal with them individually. So looking at the 2, the highlighted section is to the left of the 2. And if I'm going to the left of the 2, those are numbers like 1 and 0 and all these negatives, and those are getting smaller, less than, right? So all my values less than 2 are going to be in my solution set. So therefore I know I need a less than 2 down here as part of my solution set. And then for 8, The highlighted section goes to the right. Those are numbers like 9 and 10 and 100 and 1,000. Those numbers are becoming greater, and so this needs to be a greater than. And then the last thing I do is I look at my problem, and the problem includes equal to as well. So this is greater than or equal to, so that means I need to include the points actually equal to this 2 on that line, so I need equal to's in my solution set. So here is my solution, and it can be either x is less than or equal to 2, or x is greater than or equal to 8. And so I can pick any point less than or equal to 2 or greater than or equal to 8 to go ahead and check this in my question. So let's go ahead and do that. So a number less than 2 would be 0, so let's go ahead and plug that in. 2 times the absolute value of 0 minus 5 minus 4 is greater than or equal to 2. So if I go ahead and simplify this, 2 times the absolute value of 0 minus 5 is negative 5, minus 4 is greater than or equal to 2. The absolute value of negative 5, well, negative 5 is 5 spaces away from 0 on the number line, so that's going to equal 5. Minus 4 is greater than or equal to 2. 2 times 5 is 10, and 10 minus 4 is going to be 6, and 6 is certainly greater than or equal to 2, so that one checked out. So we checked this one as a valid solution set using 0 as our point that we substituted. And let's just do one really quickly for my other. So a number that would be greater than 8, well, 9 is greater than 8, so let's try that out. So 2, I'm going to substitute a 9 in place of the x, so 9 minus 5 minus 4 is greater than or equal to 2. So 2 times the absolute value, 9 minus 5 is 4. Minus 4 is greater than or equal to 2. The absolute value of 4 comes next. 4 is 4 spaces away from 0 on the number line, so it would be 4. Minus 4 is greater than or equal to 2. 2 times 4 is 8. 8 minus 4 is greater than 2. And 4 is, 8 minus 4 is 4. 4 is greater than or equal to 2, so that checked out as well. So our solution set is going to be every point that is less than or equal to 2, represented by this highlighted section here, and every point that's greater than or equal to 8, represented by this highlighted section here. All right, so that's how you solve an absolute value inequality graphically using a graphing calculator.